Hi, Rashid here. Thank you so much for joining. Hope you're doing well. So today's video is about when you read in a netlist into STA tools such as Tempest, then when you do report annotated parasitics, you get this assigned, this kind of assigned section. And okay, there are assigned nets, and it says all those nets are not annotated. So this came in a couple of videos ago in one of the comment, and actually I did a video during the STA training where I explains all these things, so you can watch that. And during that I said, okay, I'm gonna look into those nets later on, but I never look into it. So I did a little bit digging for that, and this video is about that. Okay, so let's get started. So report when you have read in the netlist, you have library set up, and then you read spec file, and after that, this is an important command to run so that you look at how many nets are annotated or not annotated. Okay, this complain about assign statements. So this is saying assign. There are assign statements inside Verilog Netlist, and there are 497 of those, and it's saying not all of those 100% not annotated. So question is this a problem for the design? So I analyze one of the nets, and um, that's I'm gonna show here. So this is the netlist, and I did see there were 497 assigned statements within different modules. So the netlist has, inside the netlist you have different hierarchies, different modules, and inside different modules, for example, this one is one of the outputs of a module. Okay, and what it does, it just assign one of the internal signal. I don't know if that was input or not, but it just assigns that to the output, and you can see a lot of them. But for a lot of those, I saw the same bit was going out, and I picked this one. Okay, WBS underscore dat, or yeah, under 57 is assigned 25. All right, so then I inside Tempest I track that, and I wanted to get the pin, this pin of a module. And you can, wherever this is, you can search back and look at the module definition, and you can search for the instance of that, and then try to find that instance within your design with get pins or get cells hierarchical. I did it differently. I was able to do get underscore pins star slash this, didn't get it, then it is star slash star this, and then star slash star slash star, sorry, not the last star, put this one. So I was able to find that this pin was there. This was the top level instance, and underneath there is another module, and inside there's another module, and the pin was, this pin was that, right? So then I got that pin, and then I get the net of this pin. You're familiar with this procedure if you have attended STA training, and you can see I got the net of that pin, and the net name is this. Net name is not this one, and actually getting it from this section, so it kind of flattened it. I tell you what I mean by that. So this netted, and then I did a report timing through that net. So you see that again, I got the pin, found the pin, got the net of that pin, which was actually named this, and then a report timing through that. And when I did a report timing through that, if you can see, if you come here all the way here, this is that net, and this is a transition time, this is incremental delay. So you can see that there is a transition time 0.363 nanosecond to 0.367 nanosecond. So there is a transition time change, and there is a delay there. So this net has actually wire delay. All right, so what I also did was, okay, on that net what is, I did a report delay calculation. So if you look at this, this is interesting. So it comes the last actual standard cell. So the last standard cell that is driving it is this one. You can see this is the standard cell. Okay. um, and the output pin, then it goes through this net, and the next standard cell's input pin is A1 and hold. So I did a report delay calculation from this pin to this pin, and it gave me this, and it said there are total 146 capacitances on capacitive nodes on that. Net capacitance is this, total to rise fall capacitance at this one, number of resistance are this, total resistance is this one. And then I found, okay, net delay if it's a rise and it's a fall, since this one is fall, so about delay is 0.29 if you round it, and the output transition time is 0.37 something. I think that's what point, that's something we see here. All right, so I think what's happening here is, for example, if this is the driver, and the net is going through different hierarchies, each one is a module, so it goes through different module and this module output, and then starts going into another module. I just picked a kind of, it travels through six hierarchies, five, six hierarchies, 1, 2, 3, then 4, then 5, and 6. Okay, and tool has kind of flattened it and just call it one name, which is that name. So even though it's complaining that that assign statement is not getting, it's okay, because overall our extraction tool is able to extract it, and we have proper capacitance and resistance. So in my opinion, this is okay. It's not an issue. Now this is just one net I did. So ideally, you still figure out, okay, do you need to, I mean, this is one net out of 497, right? Can you really rely on one net to get conclusion about everything? No, right? What if one of them, those nets is not? And that's something important to keep in mind. This is a sign-off tool. You cannot make those assumptions. You have to check everything. So ideally, I would not like to see those assignment statements here and this sort of complaint. So I figured on Cadence Innovus tool, which is a place and route tool. There is a variable that you can set when you're building the flow, and this is the common user interface, which is more common these days. So you can use this variable, and it's not going to introduce any new assign statements in the netlist. And if there are already, for example, you use Genus, a different synthesis, a different tool for synthesis, not like Fusion Compiler, which has everything in one, then you can use remove assigns or delete assigns commands. So you can, if you have a Fusion compiler, IC compiler, I don't remember exactly how to handle this one, but figure out there should be something similar, or if you're using some other tool, there will be something similar. So my recommendation is try to get rid of all those assign statements so that you have a clean report, annotated heuristics report. All right, sounds good. That's it for now. See you in the next video.